Thank you. So if I take that derivative, anybody know what the answer is? Square root of x plus 3. Do people understand that on the test, people might be tempted to say, well, we're going to go u to the 1/2, we're going to go x plus 3, 1, 1 over 2 roots of u. We're going to do the chain rule. Everybody understand why people are tempted to do that? That would be finding the second derivative, okay? The derivative of that, okay? So this one right here, people might be tempted to use the product rule. When you take the derivative, it just means that the integration part goes away. So the integral goes away, and what are you left with? 3x squared times secant of x. And everybody understands, again, that sometimes people would be tempted to use the chain rule in that situation. You get that? I'm sorry, the product rule. Freddie looked at me like I was crazy. He said, chain rule? It's obviously the product rule, Mr. Gibbs. What were you thinking? You're absolutely right. But it is your birthday. You're extra intelligent today. Okay. What's different about this one? Starts at x and it ends at 6. That's interesting. I wonder, let's just kind of think about it for a second. If I turn my calculator on, I go into y equals, and I go x squared, and this is the first one we ever did, and we'll calculate number 7, and we'll go from 0 to 2. And you guys all did that in your head. You know we're supposed to come up with 8/3, right? So we do it, we get 2.66 repeating, right? What if we did this? What if we did second calculate, and we chose number 7, and we said the lower limit was 2, and the upper limit was 0. What if we switched them? Negative. It turns out when you integrate to the right, you get one answer. When you integrate to the left, you get the opposite. So here's what we can do. It's very simple. This is the same thing as so what did I do in this situation? I switched the bounds. These are your bounds of integration. I switched them and made it negative. Okay? See that? So that means the derivative is equal to, anybody? Negative sine of x squared. You try the next one on your own. Go. The negative natural log of x. Piece of cake upside down. Last two problems of this unit. Way to go. You're so smart. I printed off the study guide for you so you can have it early. Letter, or this one right here. What's different about that one? It has an entire function up here, doesn't it? Yeah, it has a function. And so in that situation, so just to kind of give you an idea, if you have x squared, okay, you know that the derivative is 2x, right? But if you have sine of x, if you have that squared, what rule do you have to use? The chain rule, right? When you have a function instead of just the variable, then you have to use the chain rule. So we're going to set up the chain rule in this situation. So feel a little bit awkward at the beginning, but we'll get it figured out, don't worry. And for this purpose, I'm going to put 2x cubed on the inside. The outside part of the function is going to be the integral from 1 to, and notice how I substituted that, so I can put u there. Everybody okay with u? Because that's what u is. Then 1 over t squared minus 1 dt. Oh, sorry, t. Okay, let us take the derivative. And for those of you who are saying it doesn't really matter what variable you use, caution to you because people make mistakes on the test that way. So I'm going to be careful to write my variables like this. When I take the derivative, what are you left with for this? U over u squared minus 1. Everybody agreed? Because we say that the integral goes away and the dt goes away, and we just plug in u wherever there's a t. Are you okay with that? All right, let's do the right side. What's the derivative of 2x cubed? 6x squared. But remember, so the chain rule says that we then multiply these two together, right? And we're going to take this thing and plug it in for u. You see that? So I got two places to plug it in. So I end up with 2x cubed over, what is 2x cubed squared? 4x is 6 minus 1 times, then that's 6x squared over 1. So my end result is 12x to the 5th over 4x to the 6th minus 1. I'm pausing because I sense a question. Going once, twice, 3 times. Okay, last one. What should we do here?
Put the X on the bottom.
Yeah, X is on the bottom, so what do you want to do about that?
Well, do we have to do the same thing in negative function too?
Very good. Morgan's on her A game today. She's got a 2 here and 1 minus 4x here. So we could just switch the value then, right? So instead of negative, it would become positive. Great. And I notice instead of x, I actually have a function in that situation. So this requires the use of the chain rule. So I'm going to go ahead and implement the chain rule. What goes on the inside? Good, 1 minus 4x. And on the outside, I have the integral from what to what? 2 to u of the cubed root of sine of t, dt. Okay, derivative of 1 minus 4x, negative 4. And when you take the derivative of the integral of cubed root of sine of t dt, just cubed root of sine of u. And when you multiply those together, negative 4 cubed root of sine of 1 minus 4x. That's it. So please take out your worksheet at this time. And it looks like we've covered these couple problems. I need to work on the answer key for that part because I haven't yet. Sorry about that. And so right now you're ready to work on this. These problems are very similar to what we have done. They should go fairly quickly. You're going to notice that some involve the chain rule, some of them don't. You're also going to notice that some of them you just have to simply flip and be negative. And then back here on this side, it says, use the fundamental theorem of calculus part 2, which is what we opened with today with our checkpoint, okay, to evaluate the integral. Remember that the function must be continuous over the region of integration. If it is not continuous over the region of integration, then fundamental theorem of calculus part 2 does not apply. So let's just to kind of give you just a little hint right here. What shape does 1 plus 3y minus y squared make? A parabola. And what's the domain of a parabola? Negative infinity to infinity, right? So therefore, it's in play for all real numbers. So the bounds of integration are not an issue at all, right? The graph of x to the fifth, same thing, right? How about the graph of 3 over, what is this, x to what? I can't read it. X to the third. So where is this undefined? 0. So do the bounds go over 0? They do cross over 0, don't they? So can you use the fundamental theorem of calculus? You can't. So you need to be able to recognize if a function is discontinuous or not at a certain point a little bit.
What do you say then when you can't do it? You just say,
I would say FTC part 2 does not apply, or FTC does not apply. And that's that. You have the rest of the time to work. I'm going to hand out your study guide. When is your test? Whoa, that means you have almost a full week to prepare, doesn't it? Wow, your teacher deserves a raise. Or maybe like a candy bar or school board.